Okay, so now in the example we're going to need a ball, or ball-like shape at least, so let's make something along those lines, like that. Let's call it B1 for now, so I'll call it ball in the library. The registration point is center. Okay, call it B1. And then what we'll be doing, we'll be moving that in response to the angle when it's so the angle can be set, and then when we've set the force, we will then add the event listener. So B1 dot add event listener. We'll just get it moving. Start off with, before we start doing anything complex. This will be responding to an event, because we're going to use the enter frame on its own timeline to animate it. We'll call that move ball. Okay. We will then need to create the function move ball, so I'll create that after all the other functions we've got so far, but inside of the class. Okay, so set the function at public function move ball, which is going to respond to an event. Brackets in, and then what's going to happen is we will just try and get this going using a bit of trigonometry again. Okay, so I'm going to need a public variable of Vx, which will be the velocity in the x-axis, so that'll be a number, and in the y-axis, so what we'll do is we'll take the force that we've got and we'll split it into the components of x and y to move the ball to start off with. We will eventually also need a variable called gravity, which will also be a number, and that can equal 0.98, I suppose, for now. Or maybe even less, we'll see. Okay, so the first thing we're going to do is try and get this ball moving, and so we will split the force into its component parts, and to do that we will use so we'll be using Circa Tower, which is the way of remembering trigonometry calculations. So we will be using cosine and sine for this part to split it into its components. We use tangent to take it there actually, and if we had access to dy dx we probably could just steal it from there actually, but I'm not going to do that. When we set the angle, we will then split it just to get some practice in. So what we're going to have is Vx is going to be the cosine of the angle, which will be dot cos, which stands for cosine. We've got the x number in there, so that would be in this case force, and Vy will be my dot sine of the force, and then the move ball function, what we'll do is just quickly add those to the x and y coordinates for the ball. Dot target plus equals, so copy and paste this twice, so I'm ready for dot x dot y, and then put in there the Vx and the Vy. This is a very simplistic calculation to start off with, so it should just make it move a little bit, and should be triggered by clicking. Right, okay. Let's just double check on what we've got going on here. Public function. Aha. Probably wanted to put an equals in there. Anything else? No. Okay, so set the angle to like that. And currently it's just moving laterally. It's certainly changing direction. Okay. So we're on the right lines. Just take a break off from that. Okay, so it probably would help if I was doing this to the angle and then timesing it by the force rather than using the force, because the force is technically the hypotenuse, so we'd use an entirely different calculation. It's not really a calculation that would help in this area. Okay, so let's just give that a go again. I'll set the angle. Oh, there we go. That definitely worked like a rocket. Let's just check that again with slightly less force, perhaps. There we go. It didn't seem to work the second time. So there's some bugs in there to be worked out. And let's leave it there for now.